Hello viewers, in last video we have started about the number system conversion. So now in this video we are continuing the number system conversion. This is Nageshwari from RMK College of Engineering and Technology. So in last video we have started the decimal to binary conversion. In that we have seen the first example. Now we are going to see the same decimal to binary conversion with another example. So, now second example, that is convert. So, we can do it quickly. Convert. So, 12.125 to the base 10. That is decimal to binary only, no? That is why base 10 to the binary. Okay. So now what is the first step? So last video itself, so I have told that. So the integer, the first we have to take the integer number. So 12. Very simple. So divided by 2. So 2 6 are 12. So 0 is the remainder. Now divided by 2 once again. 2 3s are 6. So 0 is the remainder. Then again 2 1s are 2. Then 1 is the remainder. Now we have to write the number from bottom to top. Now the next one is decimal value. We have to take the decimal value and multiply it with a binary. So what is 0.125 into 2 is nothing but, so 0.250. Now consider only the integer part, that is 0, and the second time you multiply with the decimal into 2. So what is 0.25 into 2? That is nothing but 0.5. So again consider the integer value here, and the third step is multiply it by 2. Okay, multiply it by 2. So sorry, so I'll erase this 0 part. Okay. So what is 0.5 into 2 is nothing but, so 1.0. Consider the integer part alone. Now just multiply it for 3 times, that is enough. Now we have to take the numbers from top to bottom for decimal. For integer means bottom to top. Now what is the answer? So the answer is nothing but 1100.001 to the base 2. So this is how we can convert the decimal into the binary conversion. Now the second part. So the second part we are going to consider. Second part we are going to convert the decimal into octal conversion. The decimal to octal conversion. Okay. So the first part we have converted from decimal to binary. Now we are going to convert decimal to octal. Okay. So for each and every conversion I will take 2 examples and I will solve it. Okay. So now the first example is convert. So 53.47, that is decimal 2 into octal number. Okay, into octal number. So now how we can represent? Same. Consider the integer value, then divide it by 8. Okay, 8 6 are 48. Now 5 is the remainder. So just we have to represent like this. Now decimal, take a decimal, multiply it by 8. Then what is the answer? So 3.76. So consider only the integer part. Then again multiply the decimal alone with respect to 8. And the answer is 6.08. Okay. So consider the integer part. Then again multiply it with the decimal into 8. Okay. So the answer is 0.64. So consider only the integer part is 0. So only multiply it only for 3 times. That is enough. Now therefore answer for 53.47 to the base 10 is nothing but 65.360 to the base 8. So this is the answer for decimal to octal conversion. Now we'll see the second example. Okay, so the second example for decimal to octal. So convert 658.825 to the decimal value into octal. Decimal value into octal. Now again, so quickly we can do, right? Okay, so 658. Okay, so base 8. That means divided by 8. So 82. So 2 is the remainder. Then 8. Tensor. 2 is the remainder. So then 8. 1. 2 is the remainder. Now consider the decimal part 0.825 into 8. So that is the answer is 6.6. So 6 is the answer, and take the decimal value multiplied by 8, that is 4.8. Consider only the integer part is 4. Now here multiply with the decimal 0.8 into 8. So therefore 6.4. Consider the integer part is 6. Just only multiply it for 3 times. Now the answer for 658.825 to the base 10 to the octal answer is 1. See, you have to start from bottom to top. That is 1222.646 to the base 8. So now, this is the second type of conversion, that is decimal to octal conversion. Now the next one we are going to see is the decimal to hexadecimal conversion. Okay, the third part. Okay, the third part we are going to see is the decimal, okay, to hexadecimal conversion. Decimal to hexadecimal conversion. So hexadecimal conversion means what? To the base 16, or we can say to the base h. Okay, now we will see the first example, that is convert 53.47, that is decimal, to hexadecimal. Okay, to hexadecimal. So now we'll start. That is again the same method. We have to follow the same method. Whatever method we have followed for the previous examples, the same method here also we have to follow. That is, consider the integer 53 and divide it by 16. So 16, that is 3 times the 5 is the remainder. So next 0.47. So 0.47 into 16 multiplied by 16. So the answer is 7.52. Now take the integer value 7 and multiply the decimal value with the 16. Then the answer is 8.32. Okay, so that is 8 is the answer. Now the next one is 0.32. So 0.32. So multiply it with the 16. So now the answer is 5.12. So take the integer values, that is 5. Now we have to multiply for only the 3 times. Okay, so therefore the answer is, that is the answer for 53.47 to the base 10 is nothing but the answer is, so 35.785. Base 16, or we can represent 35.785 to the base h. So this is the answer. Okay, now we'll see the second example. Okay, So we'll see the second example for the third part. That is, what is the second example? That is convert. So convert. So 5386.345 to the base 10 into hexadecimal. Now, what is this step? The first step is 5386 divided by 16. Okay, so 16, that is 336 times. So 10 is the remainder. Then 16, 21, 0 is the remainder. Then 16, 1 times 5 is the remainder. Okay, then 0.345 into 16 is nothing but 5.52 as 5 is the integer part we have to consider. Then multiply the decimal part with 16. Then the answer is 8.32. Then take the integer alone, and the next step is multiply the decimal part into again 16. Then the answer is 5.12. Sorry, 5.12. So yeah. So 5.12. Then now take the integer part, that is multiply only for 3 times, that is enough. So therefore the answer for 5386.345 to the base 10, the answer is 150. Now what is the 10? The value for 10 in hexadecimal is nothing but A. I already discussed this representation of hexadecimal in the previous video. Okay, so 0.585 to the base H. So that is about the conversion of decimal to hexadecimal conversion. So far we have seen the 3 type of conversions, that is decimal to binary, decimal to octal and decimal to hexadecimal conversion. So in the next video we are going to see the binary numbers into the other 3 types. Thank you.